Good morning, good afternoon, and good evening, wherever you are joining from. In these days, everybody is remote and spread globally. So welcome to our monthly webinar series from Push Technology. Today, we'll be talking about a key topic that has been one of the highlights of 2021. It's all about architecting enterprise-grade pub/sub solution. And my name is Sanjay Marimadaya. I'm the Chief Product Officer at Push Technology. I'm based in the San Francisco Bay Area, a long-time Silicon Valley transplant. So been with Push Technology for about over 18 months now. We've had a great ride. And this is a topic of interest for several of our customers and partners. And that's the reason we chose this topic to kickstart our new year, 2022. So hopefully this will be an engaging conversation. I'm joined by my colleague, Mike Eister, who is a principal solutions engineer, a lot of experience in industry. So we'll answer a lot of questions towards the end. I'll spend about 40 minutes talking through the slides and giving the background, and we'll room for some Q&A. So to get started, let's look at the 5 key trends that are happening in the application development space. You're all familiar with it. I wanted to recap. The number one is microservices are still growing, the adoption. The second is platform as a service is really being sought even more than in the past years, primarily because the app developers and customers want to focus on the business logic. And the whole evolution of the increasing speed of the internet access and the proliferation of mobile technologies, giving the need for real time, it's pushing the boundaries of what real time is all about. And event-driven architecture is probably the thing that has caught a lot more in the last few years, primarily promoted by Kafka and all the messaging platforms in the past. And finally, there is an evolution of low code and no code requirements because of the shortage of professional developers. So Gartner's already said in one of the reports that in 2020, more than 50% of the user-facing applications were event-driven. Along with that, they estimate over 500 million new applications will be developed in the 5 years between 2020 to 25. So it's a massive amount of applications that are being developed that comes with the need for low code. In 2019, according to a Microsoft study, that the core technology, the non-core technology companies hired more developers in 2019. I think the trend is growing. Like the companies in energy, retail, healthcare, they are hiring more developers. Along with that comes a prediction that there will be over 1 million shortage in developers in the next decade, just in the US alone. So all of this puts application development as an area of focus, and there are a lot of needs that are there from the enterprises. So event data is the core that drives the application logic. So there's something that happened in your solutions. There's an event and there's a time associated with that. For example, there's a stock price change if you're in a stock market brokerage application, or it's an emergency alert that needs to be sent to your mobile application, or an incoming message in a chat, or a package delivered. You always see the moment a UPS package is delivered, in just 1 minute, you get a message, the package was delivered. Similarly, there are IoT device data. The faster we can deliver these events, the quicker will be the app. It can do something useful for your consumers. So that is the core. Event data is at the core of new applications. In whole of this presentation today, I'll be talking primarily with one data source to give an example. Rather than making it theoretical, we'll take a foreign exchange data, currency data, and how it flows to the end applications. So usually for companies dealing with Forex, and a lot of large enterprises have a lot of data sources, 200s of them, and they need to consume data, do a lot. It could be a feed handlers from exchanges or internal processes. And then there are multiple consumers for it. Could be, in this case, dealers or central banks, retail participants or hedgers, and there could be some client applications. So that is the scenario we'll take throughout this presentation today. So that is the final scenario. Let's dig a little bit deeper into this. To take all these feeds and to make it available to the consumers is where the event-driven architecture comes in. At the core, the event-driven architecture has to make it easy to consume and enable enrichment and deliver it to the consuming applications. You call it subscribers in a pub-sub context. So that is the whole core of event-driven architecture. But let's look a little bit deeper into what are the key requirements. As we spoke, there are several data feeds, feed handlers, exchange data, free data, and they all land in the data tier. It could be in Kafka or a Spark streaming. It could be a SQL or NoSQL databases, or even in a storage. It could be cloud storage or any other file system within the backend. So you know all of these technologies, Kafka. A lot of our customers have all of these databases in their data tier. And finally, there is a backend service that consumes this data, applies logic. For example, what should be a vendor's pricing strategy for foreign exchange to meet their P&L? So, and they publish it to the pub-sub, which has an event broker, which is the key. And every time there is a change, you'll have to go back and make this backend service changes. That is one, takes a lot of time, limits your agility. So customers want to make sure that they don't have to go back and forth. So the pub-sub has to provide the ability for self-service. That's one key thing. The second is from a time to market and maintainability, the backend services has to be brought to minimalism. You don't need to do a lot of service. It is better. It is done in the platform. That's the other requirement that comes in. Another requirement here is to, sometimes there is no backend processing need to be done. You need to connect the data source directly to the pub-sub and distribute it. That's another requirement that comes in. Once the subscribers come into the picture, there might be an audit system that wants to consume all the data that is published. That's one requirement for another consuming application that is within the data center. But there might be another risk modeling module that may not need all the data, but needs a subset of the data. Can the event broker and the pub-sub platform deliver it? Otherwise, the consumer application will have to delete a lot of processing happens. That might be okay in the context of within a data center because you have a powerful server. What happens when you have to distribute data over the internet, a web, mobile, or IoT application? The IoT application might need just a precise data, so that doesn't need to do any processing, just display it on the console that it has. Or a web application might need a lot more data for the extensive features that provides. Mobile will have different requirements. Another point is the network bandwidth they work with. So each of these devices will have different network connections, and the stability of the connection is also an issue. So there'll be reconnections happening. There'll be dropped connections, which we are all familiar with as you walk around in the neighborhood. So there are a lot of requirements that go into when you are looking at an enterprise grade solution. Again, think about the number of connections. So there should be scalability is another big consideration. So when you're thinking of a pub-sub, there are multiple options. There are 3 event brokers in the market. Not that, just to give a sense, but not all of them will have all the features that are required. You are aware of a log-oriented broker like Kafka, which is primarily good at retention and replay of high throughput data. Because if you look at Kafka came from LinkedIn, they had to distribute within the data center the entire data. That's where it will be popular. It's log, it is retained, and you can subscribe to data at any point. Then there are queue-based brokers like RabbitMQ, and then subscription-oriented event brokers like Google Firebase, which Google acquired. But all of them have different features and limitations. But then the borders are diminishing. And today we'll look at another event broker that takes a lot of capabilities from all these 3 to meet some of the needs for enterprises. So to summarize the requirements for an enterprise grade solution or a pub-sub solution, number 1 is massive scalability in topics and connection. Topics are how event data is organized for subscribing applications to consume. Right? So millions of topics and connections are important. Second, efficient use of bandwidth is required during distribution, because then you need to reduce the cost of data distribution. This should be flow control, delay, and conflation. A lot of requirements are there in features will enable this efficient use of bandwidth. And again, flexibility of data modeling. You don't need to go back to the backend engineers to re-architect and push data differently. So agility and simplification of backend services is important. And the client application, you need to simplify it. You don't need to consume too much data. Otherwise, the client application size will grow. It may not sit in the mobile or IoT. So simplification of the client software is required so that you can launch products faster. And support for open protocols and interfaces also become very important. MQT, REST, HTTP and PubSub, as well as request response. So these are all the requirements that has come with the 10 plus years we have been working in the industry now. So what does this translate to the capabilities of a PubSub solution that you are deploying? Number one is it has to be a real-time event broker with real-time streams processing functionality. That's one of the key criteria. Second is deep hierarchical topic trees are required so that you can send specific data and enable you to reorganize the data to the needs of various subscribers. We'll talk a lot more about this today. And the third is security. You need to be able to apply security at a fine-grained level, not at a very top level, so that limits your ability. Otherwise, you'll see more examples today that then you have to start publishing data in different way to control the security. That adds more work on the backend processes. So these are the three key things to look for in a PubSub platform. So let us today take a look at an enterprise-grade PubSub solution in the context of the foreign exchange data. So we are introducing our product, which you're all familiar with. It's a holistic PubSub platform for real-time application. So we call it Diffusion Intelligent Event Data Platform. It's a holistic platform that makes it easy to consume, enrich, and deliver event data. To do that, first you need to look at the data sources. So we have a component called Data Gateway that makes it easy to integrate with various data sources. I'll communicate. We already have pre-bid adapters, and we are going to release within a month on a whole overhauled gateway framework that will make it even more easier to build connectors with minimal effort. The second, as you consume the data, the enrichment part is where we have the data wrangling capability, which has, with the diffusion, you have deep hierarchical topic trees that enable you to wrangle, and we have a low-code interface in addition to SDKs to manipulate and reorganize the data. And third, most importantly, is our event broker for distribution that has a lot of capabilities. We support multiple protocols as well as delta streaming to reduce the bandwidth. A lot of flow control features we'll talk in detail in the webinar. So with all of these features, the whole purpose of this platform is to reduce the development efforts, the time to market, as well as operational costs of delivering real-time events. So we have SDKs in all popular programming languages, and this platform is being deployed on-premise. There's a cloud version as well as hybrid. Our customers are using that. So we'll talk about all the enterprise-grade requirements in the context of foreign exchange data, and of course, in the context of diffusion. So let's first get through the pre-built integration for data sources. Today, we have connectors, pre-built adapter for Kafka, REST API, as well as databases. Believe it or not, right now, still a lot of data for events resides in databases. So we have a change data capture adapter based on Debezium open source product, and Redis. We have Redis connector as well. It's a tutorial right now. We'll be integrating that into the framework soon. So with pre-built adapters, you can integrate these data sources directly, and you can create topics instantaneously. So let's say all the FX data from in Kafka can be put under one topic called Kafka FX. Then if you have databases, you can have a database A and create subtopics called table 1, table 2, and table 3. And then REST, you can get the REST API. You might have an open sky network for flight tracking information. You can add that as another topic in the main topic tree. But this is the first step. Then today we'll talk about all the data wrangling capabilities that we have. You can take this data and reorganize it with all the processing to make it available to all the subscribers in the way they need it. So let's take the structure of a complex FX data. This is the data that you would receive into the PubSub. It's a JSON structure with a lot of arrays and sub-JSON structure. If you look at a code beautified to make it simpler, this is the currency pair with 10 currency pairs with 3 pricing tiers per currency pair. What happens is there are limitations of existing lot of flat PubSub solutions. They have a flat topic tree. What happens is you collect the data and push it into the PubSub platform. And let's say there is a client who wants to subscribe to Forex topic. You get it and you get the entire 10 currency pairs. It could be 10K bytes in size. But what if you want the client application developers come and ask, I need only the tier 0 for X price. You have to go back to the backend service to republish only the tier 0 data as another topic here. So it's just a lot of back and forth. The same thing, imagine all the other questions that might come. So in order to support the needs of various subscribers, there's a lot of back and forth. It limits your agility and flexibility. So to address this, Diffusion has a hierarchical topic tree, which is really the key for enriching data. So at the core of our data wrangling capabilities in Diffusion is a domain-specific language. It's a low-code interface available through our console. And again, you can do all the capabilities I'm describing today through programmatically through our SDKs as well. The key thing to note with our SDK is it's all WebSocket based, so the connections are long-lived. So there are a few things that we will discuss today. First is automatic topic creation. Let's say you get a fire hose of data. Would it not be great to have the subtopics automatically created? We'll discuss that in the next slide. The second one is we'll see how you can expand and create deep hierarchical topic trees to deliver fine-grained distribution or give the ability for the client to subscribe to the level of information they need. And there is topic views, which is more like a virtual topic tree for dynamically rearranging the topic structure without having to copy data. And then personalization is very important. We all have freemium, right? Free customer, paid, and there is a platinum or a VIP customer. How do you customize the data based on their profile parameters? We'll talk about that. And then finally, there is a lot of transformation and enrichment capabilities, ability to add data to a topic data, remove, mask. These are all the enterprise grade requirements that we have. So that provides flexibility without having to go back to the backend engineers. So let's first take how we create dynamical topic trees. Say, take an example. In this case, we need to automatically create topic trees per currency pair. Let's say you have 10 currency pair. What if the data stream suddenly has another currency pair that has been added? Now you don't need to do any work in the backend. With one command, the way it is set up, you can automatically create topic trees. You have a main topic tree called currency, and there are child nodes with currency pairs, and the subscribers can subscribe to any level, let's say Australian dollar to US dollar, and they get exactly that data. It's a very simple command with what is the incoming topic tree and how we want. And there's a command called expand, which automatically expands the next tier. And let's take a next example. Subscriber wants to subscribe just to tier 0 price. That's much easier. Now that in the previous example, the client will get all the 3 tier prices. That might be a little too much, and they want only the single currency pair. So in that case, you can subscribe to just with one command, you can subscribe to just the data that you need. So let's take the scenario where a client has to subscribe to just the tier 0 price. So in that case, again, we can automatically expand to the next level to provide the deep hierarchical topic tree. So again, another command, simple commands to expand to the next tier automatically. So all of these can be done on the console without having to go back to developers. A data architect can do that. So let's look at this next example. You want to, the situation changes and there is another dealer wants to get tier 0 price for all the currency pairs, not just one. How do you re-architect? Look at the structure of the data. With Diffusion, you already have created the currency pairs. You can still have all the currency pairs, and you can recreate another child node called price by tiers with just another command. This is where the virtual topic trees comes into picture. So you can reorganize the data. Now the subscribing client can connect to just the price tier /0, and you get currencies for all tier 0 price for all currency pairs. That's how flexible it is. Now imagine you don't want to expose the concept of tier 0, tier 1, or tier 2. What about if a client subscribes and you want to distribute a tier 0 price, tier 1, or tier 2 price based on their profile, whether they're a free or a paid customer? That's where personalization comes into picture. So with personalization, what we do is, let's take a client subscribes to currencies like US dollar to US, Australian dollar to US dollar, and a platinum customer needs to get tier 0 price, and you decide that gold customers get tier 1 and silver customers get tier 2 price. And they should be oblivious to the tier 0, 1 to 1 pricing. So what you do is, you can, as you have set it up in the previous slide, you can have these various tree structures allocated, and there is a concept of session tree rules where you can assign rules on from which tree to which topic tree to distribute the data. So for example, you have a rule here, a session filter. So here we check, you can set it up as an admin. If the profile has broker platinum permission, point them to $, to 0. Broker is gold, it should be the tier 1 price, and silver, it will be to tier 2 pricing. All these can be done through session trees for personalization. There's a table, it's in the backend, administrator controlled. So that way now you're distributing data specific to what customers need and based on their permissions and subscription levels. So let's talk about the roles. How do you assign roles? I want to cover in this context. Roles, we have 3 things to consider: the user, the role, and the permission. The permission, these are the 3 things to consider when you're creating accounts. So permissions are predefined. Whether you can acquire a topic, select a topic, read, update, modify. Not everybody will be allowed to update programmatically. So that's permissions are predefined. Roles, we also have predefined roles like a client or a topic controller, authentication handler, or administrator. You can also add roles like the gold, bronze, and platinum. You can add those roles as well. So this is where the admin comes into picture. And once you have the roles, and you can assign roles to the users. We also, the platform comes with pre-built users like client, admin, and you can have anonymous connections. And you can assign what roles each of these users have. And that can be done on the console. So let's say you are adding a new role, FX hedge role, and you can give global permissions to what this particular role can do. It could be just reading, for example, no modification or updates. And then you can also give specific paths to which this role will have access to, currencies or Australian dollar to US dollar. So you can have all of these permissions built in. And when you create a new user, you can assign roles to that particular user. It can be done programmatically through the handler as well. So this is how you assign roles and create personalization. The final part I want to talk, at least in the context of streams processing, is how do we enrich data, without having to go back to the backend engineers, or you can do it very quickly on the platform. Let's say you want to insert previous day's price into your data stream that you're sending. So to do that, you bring in the data from a previous close. Every midnight, you can have a process to publish the data from previous day, or move the data from one of the topic tree into another topic tree called previous day close. And that only contains the currency pair and maybe the previous close. And you do that with, and again, you are creating a new, you want to create a new topic called enriched. All you need to do is one command to insert the data from this particular tree into the data coming in from primary data, FX incoming data. So you can add it at the end of the JSON structure. What about you want, if there is a, for example, you notice a redundant data and you want to remove it, a remove command will remove one field. In this case, the pair name is redundant. You can remove that particular entry with just one command. There might be a need to replace it. For example, masking. You don't want to, for a tier 0 price, you don't want to disclose the previous do price. You can replace the previous do price with blank or make it 0, for example. And you can also, there are several other commands that are available to add, move, copy, test. Testing is just to make sure that you can test programmatically if what you are sending is what the operation you just performed is what is actually being implemented. So a lot more capabilities, and we'll be adding more as customers ask for more features. The next part is flow control, very critical. As we discussed in the past, you may want to first, for certain free customers, you want to delay sending data by 5 seconds. You don't send the data immediately. There's a delay of 5 seconds or 1 hour, whatever you want to do it. So in that case, all you need is to add one small command to the DSL, that delay by 5 seconds when you create a topic tree, right? How about throttling? You want to send only 2 updates for silver profile customers. Every 5 seconds, you will send 2 or 3, or you can have, if you are getting updates every 10 seconds, you'll only want to, every second, you want to send only 2 updates on every 5 seconds. You can use the throttle parameter when you create a topic tree. Finally, conflate. This is server level setting. When there is a customer, when a client accidentally disconnects and reconnects, you can set up global policy that you start sending from the current data. So you can also change that with parameters to have different way of sending data. You can start from where you left off. So conflation parameters are also available for flow control, and there are more features that are available. These are some of the key features from a flow control. And finally, reliable connections. As I just mentioned in the previous slide, what a client connects and disconnects and wants to reconnect. So we have recovery buffers on both the server as well as the client, so that no information is lost. You can have a global parameter on how long to retain the messages. So let's say a customer, the server had sent message 2, but the client did not receive by the time it disconnected. So when they reconnect, they synchronize and start communicating from where they left off based on various parameters. So there's no disconnect. So you have a parameter to say how long the sessions have to be maintained and where the data flow restarts. So there are some parameters to control this, lot of capabilities here. So you can have, when you make a connection, you can have reconnection timeout. When there's a disconnect, how long you want to retry. And then if you're not sending data, you can have a pre-configured handler to test the health of the connection. And you can have a custom reconnection handler because you may have some logic on the client side. And also we have callback function when there is a disconnect or a reconnect or a close happens. On the server side, we can maintain the server side recovery buffers and conflation setting. So a brief overview of reliable client session. This is absolutely a must-have requirement in an enterprise-grade solution. And the final component on the delivery side is our proprietary delta streaming for efficient use of bandwidth. So let's say you are sent a message, take a hypothetical example, currency pair and the previous close price was being distributed. And the only entity that has changed in the previous close, and it's still the same market. And let's say the next price you sent is like 71 cents. Now with delta streaming enabled, diffusion only sends the bytes that have changed and adds protocol header, and the diffusion SDKs on the client side or the consuming side will reassemble the entire packet before sending the message to the client application. So this has a huge benefit. In one of the examples, over 90 days, there were 80 gigabytes of messages that were sent with delta streaming off. With delta streaming enabled, it was less than 16 gigabytes, over 80% saving in bandwidth. And most of our customers get about around 95%. It all depends on the logic of what data you are distributing. So this is a massive saving. It not only saves bandwidth, it also improves the performance. This is one of the key differentiators, and it can be enabled or disabled. If you use REST API, naturally, interface, you will not be benefiting from delta streaming. Finally, Kafka is primarily used in all the large enterprises. Diffusion seamlessly plugs into Kafka. You can combine with Kafka, and that's what many customers are using. Let's say your central office distributes data only through Kafka, and your regional office gets data through a Kafka pipe. Many a times they were scaling the derivative pricing or audit dashboards primarily to keep up with the volume of data, and most of the scaling was required only to drop packets. With diffusion plugged in front of Kafka, now each of these consuming module gets only the data that they need, and they don't have to scale these other modules within the data center. And because of the hierarchical topic tree and all the features we described, you can send exactly the message that these consuming applications need. So this is something to keep in mind as well. And finally, diffusion is not a single instance. You can have geographically deployed diffusion, one in Asia, Europe, and Americas, and you can all connect them through remote topic views. That way you get data what you need from various sources. So data distribution globally becomes much easier. So each of these topics will go in detail in future webinars. I wanted to highlight the fact that you can build an event data mesh with diffusion. And in summary, when you think about enterprise grade solution, you have to totally have a different view of what real time is. So you need to think about how to remove complexity of your applications. We make it easy to build application for developers. Architects don't need to worry about scalability. The architecture of the product is seamlessly scales with a cluster deployment from a pub-sub point of view. Product teams can innovate very quickly. We have companies adding new features during the event. For example, some of the gaming solutions added new capabilities and new monetizing solutions, even during the middle of a World Cup a few years ago. And security is paramount for us for an enterprise-grade solution. So we have added security at every layer, from consumption to enrichment and delivery. And finally, the cost of operation is significantly reduced in the time and cost it takes to develop, to maintain, as well as distribute infrastructure cost. So low-code development is one of the key features. You can have it as SaaS, on-premise, or hybrid, and the platform supports multiple modules. So where do we go from here? All right. So the learning path for diffusion is we have built a lot of products on our website. The first place to learn about this, you can go to pushtechnology.com/diffusion-playground. You can go immediately. You don't need to be a developer. We have 3 applications there: NBA scoreboard, a flight tracker, and a foreign exchange data. These are all live feeds, 3 sample applications with the front end. You can see a question, for example, in case of a flight tracker, you may want to check what are the flights that have landed, or flights that are above a certain altitude, or flights that are with the speed of flights. These are some rudimentary questions that an app would address. And you can look at the topic tree as well. A very interactive playground to learn about. And you also have opportunity to enhance it. All the source code is available for you to modify themes to get familiar with the platform and learn PubSub. So this is probably the first place to get familiar with the capabilities. And the second is we have fully functioning tutorials with source code on our website, and you can deploy them for free on Diffusion Cloud, 90 days free. A lot of our customers start there and go from there to get a paid version. We have a tutorial for PubSub to take data from your Redis into Diffusion. We have many tutorials for Kafka. And if you're building a chat solution, we have a fully functioning real-time messaging app as well. These are just the 3 tutorials that I'm highlighting. There are many more tutorials on specific features as well. So sign up for Diffusion Cloud and play around with on the dashboard as well. So in summary, we've been around in the industry for 15 years with a lot of experience and a lot of validation on the value by our customers, and with awards we have won. So with that, I'll pause here for any questions I'll be able to take, or my colleague, Mike Eister, will also jump in if you have more detailed questions. Do you see any questions there, Mike?
Hey, Sanjay, there is one. You had mentioned there are different broker types for an EDA. How does Diffusion fit in when a company already has Kafka as their EDA broker?
So Kafka is primarily a log-based event broker. So that means Kafka is fantastic when you have stored the data and there are subscribers coming at different times and they want to consume all the data. Kafka is great. But when they have to consume all the data, the challenge becomes, again, a fire hose of data. So Diffusion easily fits in front of Kafka. Diffusion primarily started as a queue-based event broker, but we have added more subscription rules. So we are moving more towards a subscription event broker, just similar to Google Firebase. But the deep hierarchical topic tree is what differentiates Diffusion from Firebase. And a lot of Firebase customers are also looking into Diffusion, including some of the big, promoted even by Google as well, to use Diffusion for specific use cases. So Diffusion is primarily a queue-based event broker with a lot of capabilities for a subscription event broker. And one more thing I'll point there, good question. We also have a topic tree called time series, where you can store, depending on the amount of data disk space you have, you can convert that into a log-based as well. You can retain the last 1,500 messages or however you configure with time series.
Thanks, Sanjay. There's another question. Can you please talk about the standout differences between a message queue and Diffusion? Does Diffusion support queuing?
So Diffusion, as I said, with time series, you can support queuing. You can queue messages. You can accumulate messages in a time series, and then a new connection comes in, they can consume all the data that has come in the last 10 minutes, if they so desire, or they can get the latest data. So queuing is allowed with time series topic feature. Anything else you want to add, Mike, to that question?
There's queuing on a couple of different levels, right? So there's queuing on the time series, being able to store historical events and messages as they are flowing through Diffusion. And then there is queuing as well in terms of reconnection. So if let's say your client disconnects, events that are streaming are still queued for that client. And when the client reconnects, those queued messages will be distributed to that client. We can leave that turned on, or as Sanjay had mentioned, we have conflation service as well to only send the latest version, but there's queuing both at that historical value and at the reconnection strategy level as well.
Any other question from the audience?
Does Delta kick in always?
Yes, by default, when you use SDKs, Delta is enabled, but that can be disabled as well.
And the other question here was regardless of quantum of data, and I believe you've answered that.
And the Delta streaming, the thing about Delta streaming is we make a judgment call. If the data has changed a lot, we might take more time developing the deltas than distributing. So in that case, we make a decision when not to do Delta streaming. There is that intelligence built into the product.
Those are all the questions I see, Sanjay.
All right, fantastic. If there are no more questions, we'll give back time. Thanks for your time, and this will be recorded. You'll get the recording, and looking forward to working with you, and you can reach out to Mike or myself for further conversations. So thank you. Have a fantastic rest of your day or the fantastic evening. Cheers.